Good day, everyone. In this video, I am going to discuss Cambridge IGCSE Physics Paper 4, which is May, June 2024, Paper 43. So are you excited? Let us get started. Now, we start with the first question first. Let me read out the question. A ball of mass 130 gram is launched from the ground at an initial velocity of 14 meter per second vertically upwards. Now, it decelerates until it is at rest momentarily at a height h above the ground. So the ball just go up until reaching a certain height, which is h, and then the ball is at rest. Yes, which is also true because every object, before it is changing the direction, it has to rest first. That is important tip for you. Now, A, define deceleration. Now, in this case, it is not about acceleration. It is about deceleration. What is deceleration? Now, deceleration means the decrease. You have to write this down. Decrease is a keyword in the rate of change of velocity. Still remember the definition of acceleration? Acceleration is defined as rate of change of velocity. That is the definition of acceleration. But when it is about deceleration, it is a decrease in acceleration. Now, B, the acceleration of free fall is 9.8 meter per second square. Show that the time taken for the ball to reach the height h is 1.4 second. Ignore the effect of air resistance. So how are we going to show that? Remember, B is related to part A. So you look at A. A is deceleration. So I'm going to write down the equation of acceleration because deceleration and acceleration share the same equation. It's just that deceleration means the negative of acceleration. So I put A is equal to V minus U over T. What is the V represents? So V represents the final velocity. U represents the initial velocity and T represents the time. So since this is about deceleration, so I have to put a negative to my acceleration. And then the ball, remember they talk about the ball reaching the height h and then stop, right? So the v must be equal to 0. The initial velocity is given here, which is 14 meter per second. So I'll just put here as 14 meter per second divided by t. I just need to prove my t, which is equal to 1.4 second. Now I make t as a subject, negative 14 divided by negative 9.8. So the t that I got, you put more significant figures because at the end of the time, you need to round off to 1.4 second. Please remember, do not straight away put it as 1.4 second, right? Put it as more, take more significant figures. So 1.429 second is my answer. So that is why I round it off to 1.4 second. Ta-da, proven. Now C, calculate H, ignore the effect of air resistance. To calculate the H, remember to talk about the ball is being launched vertically upwards and then the ball stops at a height. This is like principle of conservation of energy. So if you can still remember, the principle of conservation of energy states that energy cannot be created nor destroyed, but can change from one shape to another shape. So this is when the ball is initially launched upwards with an initial velocity, right? The ball has kinetic energy. It is the kinetic energy of the ball that is being converted to gravitational potential energy of the ball. I am definitely going to use that. So I will say that kinetic energy, Ke means kinetic energy of the ball, is being converted to gravitational potential energy of the ball. Now, all you need to do is just to recall the equation of kinetic energy, which is half mv squared is equal to mgh. Can you see that I do not need the mass of the ball because I can just cancel it off. Now, half v is my initial velocity, which is 14. So I just put 14 and I square it. G is 9.8 and this is a height. just make height as a subject. Height is equal to 14 square divided by 2 times 9.8. So the height that I got was 10 meter. So 10 meter is the answer. Now, D, the ball is dropped from the top of a tall building. Describe and explain the motion of the ball as it falls. Consider the effect of air resistance in your answer. Now, this type of question is super duper important and super duper popular. So, what are you supposed to write down? Now, I want you to look at the mark allocated here, which is 3 marks. When it is about 3 marks, it is suggested, I strongly suggest you to split out your answer into 3 important points, 3 stages in this case. Now, I split out into 3 stages as well. So I talk about start from the fall. Yeah, at the start of the fall, you have to remember the ball starts from rest because the ball is at the top of a building. So the ball is initially at rest. And you have to understand that air resistance will increase only when the speed of the ball is increasing. So when the ball is at rest, basically the ball does not experience any air resistance. So I say at the start of the fall, air resistance is equal to 0. You know why? Because the ball is at rest. So the only force that acts on the ball is the weight of the ball. So the weight of the ball will give the balls an initial acceleration, which is gravitational acceleration. The value of gravitational acceleration is 9.8 meter per second square because, first of all, it is given here. Or if it is not given, no problem. You can scroll up to instruction, the last point. Acceleration of free fall is 9.8 meter per second square. So I just use that. That is my first point. And when the ball is dropping, you know that gravitational potential energy of the ball is going to be converted to kinetic energy plus the work done to overcome the air resistances, right? So I say that the speed of the ball is increasing because when the ball is dropping, yeah, the speed will go faster. What happens next is that the air resistance will also increase. Why? Because the speed of the ball is increasing, air resistance adds when the speed of the ball is increasing. So the resultant force, how do I calculate resultant force? Now I will draw the ball here so that you can see it clearer. So you just imagine that this is my ball. Ball is falling. This is the weight of the ball. When the speed of the ball is increasing, air resistance is the force that opposing the motion of the ball. This is called air resistance. So I want you to see this. The two forces are acting in opposite direction. How do you find the resultant force? Resultant force in this case is equal to the weight minus air resistance. So since the weight need to minus something, therefore the resultant force is decreasing. What happens when the resultant force is decreasing? The acceleration of the ball will also decrease. Because the resultant force on the ball is decreasing, therefore the acceleration will have to decrease. F equals ma. F is directly proportional to A. A means acceleration. So that is the second stage. And the third stage comes to 1 point. So the speed of the ball will increase to 1 point where the speed reaches its maximum value. So what happened next is that because the speed is maximum, air resistance will have to increase to its maximum value. The maximum value of the air resistance is equal to the weight of the ball. It cannot increase further than the weight of the ball. So when the air resistance offset or balances the weight of the ball, resultant force is equal to 0. You see, you take a number minus the same amount, you will get 0. So therefore, the resultant force on the ball is equal to 0. When the resultant force acting on the ball is equal to 0, the acceleration of the ball is also equal to 0. So at that moment onwards, the ball will fall with a certain maximum velocity. We call it as terminal velocity. That is how the terminal velocity is being achieved. Now, the second question, Fig 2.1 shows solar-powered traffic warning lights. The energy from the solar cell is stored in a battery. Name the energy stored in the battery. Energy stored in the battery is always chemical energy. So we just write chemical energy. B, the two lights in Fig 2.1 are connected in parallel. State one advantage of parallel connection in lighting circuit. So when you connect in parallel, that means they connect, okay, up and down. Side by side is called series. So what is the advantage of parallel? When one circuit is shorted, the other circuit can still work. That is one of the advantages. C, the efficiency of the solar cell is 22%. The power supplied to the lights by the cell is 15 watt. First part, state what is meant by 22% efficiency. So it means that the useful output power is 22 over 100 of input power. So do you know why we calculate the efficiency? Is to see like how much useful output energy, useful output work, or useful output power can be converted from a certain cell, maybe cell, solar cell, or generator, or motor, etc. Now, the second part, calculate the power, solar power input to the solar cell. So I am going to use, because power is given, so I'm going to use output power. PO means output power, divided by input power times 100% is equal to 22% because the efficiency is already been given. Output power, because power supplied to the light by the solar cell, that is the output power, which is 15 divided by input power times 100%, which is equal to 22%. So input power is equal to 22% divided by 100%. Oh no, sorry, cross multiplication. So you cross multiply, you could see 15 times 100% divide 22% is equal to my input power. Therefore, input power is equal to 68 watt. 68 watt is the answer. D suggests two advantages of using a solar cell to power the traffic warning lights in Fig 2.1 compared to using mains electricity. First one, maybe less power loss. Do you know why less power loss? Because less wires or less connecting LEDs are being used. Because connecting LEDs, they have certain amounts of resistances. So I don't want to add to that. So that is why when we try to connect a circuit, we try to limit the connecting LEDs because after all, it will give out heat and it will add to the total resistance and it will give rise to power loss. So that is why I say when you use this, less power is being lost. Now, and the circuit can still working if the main power is being cut. So those are the advantages of using solar cell. Now, question number 3, Fig 3.1 shows two children balance on a seesaw. A seesaw is a length of wood which rotates about a central pivot or fulcrum. Child B moves 0.05 meter further away from the pivot. Could you see that it moves? The child B is moving backwards. Explain why the seesaw rotates clockwise. Now, in order for you to explain that, okay, how do I know that this is clockwise rotation? You have to calculate the moment. Let us recall a little bit about moment. Moment is being defined as force multiplies by perpendicular distance from the pivot. So I need to identify which child gives clockwise moment, rotates clockwise moment, and which child will rotate anti-clockwise. Look at child A and identify your pivot first. Okay, my pivot is here. Child A, the weight of child A is going downwards. While going down, it will be seeking for its pivot. So it has to turn in this direction. And this direction is called anti-clockwise or anti-clockwise direction. Whereas child B, look at the weight of child B, which is 900 Newton, is going downwards. While going downwards, it will be turning towards the pivot. This is called clockwise direction. So the seesaw rotates clockwise direction because the clockwise moment given by child B is larger as compared to the moment given by child A. That is why the seesaw will rotate clockwise. So that is the answer. So I say that because clockwise moment is, because this is only one mark, larger than anti-clockwise moment. Now the second part, child A puts on a backpack and the seesaw now balances. Calculate the mass of backpack. First, I need to, okay, when you see this is a keyword, balances, it also means that anti-clockwise moment equals clockwise moment. Since I need to find the mass of the backpack, I don't know the total force given by child A. So I'll just put it as F. F times the perpendicular distance, which is 1.6 between the force on child A and the pivot, which is equal to the clockwise moment, which is the force 900 Newton, times, remember what they told you? They said that child B moves 0.05 meter away from the pivot. So you have to be extra careful. Use the distance between child B and the pivot added with 0.05 meter. So the distance will become 0.8 plus 0.05 meter. So beware with this type of question. It's quite tricky. So I got my F value, which is 478 Newton. But look back at the question. The question is asking for the mass of the backpack. So I know that the force that I got is the force of child A plus the force of the back. I don't put B, I just put back. Is that okay? Force of backpack. Now I just replace this with 478. Force of child A, which is the weight of child A, is 450 Newton plus the force by the back. So I find my force by the back, which is equal to 28 Newton. How do I get that? I just take 478 Newton minus 450 Newton. So they ask for mass. So F equals mg. 9.8. So therefore my mass is equal to 28 divide 9.8, which is 2.87 kilogram. That is the mass of the backpack. Part B, the concrete floor under the seesaw is replaced with a rubber floor. A child falls from the seesaw and experiences an impulse when they hit the floor. First part, define impulse. When you are asked to define impulse, right, you can write it in symbol Ft, or you can write force multiplies by time, or you can also write product of force and time. That is impulse. Now the second part, explain how the rubber floor reduces injury to the child use ideas about impulse, force, momentum, and time in your answer. So they say that this child falls from a seesaw, experiences an impulse when they hit the floor, right? The problem is that, okay, the impulse is still the same, right? It is a product of force and time, right? So what to do with when we use the rubber floor, right, instead of a concrete floor? You know, rubber floor would absorb the child. So you could see that the child will be absorbed a little bit by the rubber floor. Why we need that absorption? It's not really absorbing, it's like time of impact, the time of contact between the child and the rubber floor. So will be prolonged. So what to do with the prolonged time? It will decrease the force or impulsive force acting on the child. Because when the impulsive force acting on the child is large, then it will cause serious injuries. So I will use that to explain. Okay, I will use equation to explain. Impulse is constant. Okay, I want you to see this. This is my impulse. Impulse equals force multiplies by time. Since the impulse is constant, I would say that force is inversely proportional to time. So rubber floor increases, or you can say prolong, increases the time of impact. Since the time increases, what happens to the force? The force, okay, so impulsive force acting, impulsive force acting on child is reduced. So that's the answer. Question number 4. Fig 4.1 shows a stainless steel saucepan being heated on an electric cooker. The saucepan contains water. A, state what happens to the water particles as the water temperature increases. What happens when the temperature increases? Don't you think temperature has a close connection to kinetic energy of the particles? So definitely the kinetic energy of the water particles will increase. So what happens to the water particle? The water particles will vibrate or will move more vigorously. So I will say, okay, kinetic energy of water particles, because temperature is related to kinetic energy. Water particles increases. That's all. Or you can say that water particles move faster. Yes, it is true. B, the saucepan contains 250 cm cube of water. Specific heat capacity of water is 4,200 joules per kilogram per degree Celsius. Density of the water is 1,000 kilogram per meter cube. Show that the mass of the water in the saucepan is 0.25 kilogram. Now, when you see this kind of question, right, and the marks given is only 2 marks, and they give you, look at the information given, they give you the volume, they give you the density. To find the mass, you use a simpler equation, which density equals mass per volume. That is why your mass equals density multiplies by volume. Density is 1,000. But hey, beware of this because the unit of density, could you see, kilogram per meter cube? And the unit of your volume is in cm cube. That is super duper big trick there. Could you see that? Therefore, you need to change the volume from cm cube to meter cube. Let me get you a little bit of how to change the volume, right? So 1 cm is equal to 1 over 100 meter. 1 cm cube is equal to 1 over 100 meter. The whole thing here, you have to cube it. So you have 1, 2, 3, 4, 5, 6 meter cube. This is 1 cm cube. Now you have 250 cm cube. So 250 cm cube is equal to 250 times 1 over 1, 2, 3, 4, 5, 6 meter cube. Get an answer for this one. We do it. 250. I got 2.5 times 10 to the power -4 meter cube. All you need to do, sub into your equation of volume, which is 2.5 times 10 to the power -4. Then you will end up getting the exact answer, which is 0.25 kilogram. Now, the second part, calculate the energy required to increase the water temperature. Increase the water temperature from 20 degrees Celsius to 65 degrees Celsius. Could you see that specific heat capacity is given? So when a specific heat capacity is given, all you need to do is just to use E equals mc delta T, where E represents energy, M represents the mass of the water, C represents the specific heat capacity of water, and delta T represents the change in temperature of the water. So the mass is given, which is 0.25, because you are asked to prove, remember? And then the specific heat capacity is 4,200, and the change in temperature, you just take the larger temperature minus the smaller temperature. That will do. And let your calculator handle the rest. The answer is 4.73 times 10 to the power 3 joules, or 4.7. Yeah, not a problem. So 10 to the power 3 joules. So that's the answer. Now, the second part, the heater supplies enough power to heat the water in 39 seconds. A student measures the time taken to heat the water as 115 seconds. Such as why the actual time to heat the water is longer. Assume that the student takes accurate measurements. No mistake. Right? You know that when the experiment is being conducted in the lab or in open air, right? The surroundings temperature will have different temperature as the temperature of the water. So that is heat. That is the problem with the heat. Heat can transfer in all direction whenever the temperatures are different until the surroundings temperature and the temperature of the water is the same, then the heat will stop transferring. So the answer is sum of heat supplied. Supplied by what? Supplied by heater is lost to surroundings. That is why it needs to take a longer time. Right. C, the stainless steel saucepan is replaced with an aluminum saucepan of the same mass. It contains the same volume of water. Specific heat capacity of the stainless steel is 500 joules per kilogram per degree Celsius, whereas the specific heat capacity of aluminum, which is higher, which is 890 joules per kilogram per degree Celsius. Explain how using an aluminum saucepan will affect the time taken to heat the water. Now, since they give the specific heat capacity, I teach you the easier way to do it. Whenever you see this type of question, right, when they have two different values, it is important that you write down the equation to relate them all. So I will use E equals mc delta T. They said that, they mentioned that mass is the same and same volume of water. So I would say that, oh, instead of using energy, because I need to relate to time, I will further break this down. Energy is equal to power times time, which is mc delta T. Now, I would say that power supplied by the heater will be the same. And then the change in the temperature will be the same. So the time will be affected by the specific heat capacity. Could you see that these two, time and specific heat capacity, are directly proportional to each other? So that is why when the specific heat capacity is higher, or in other words, specific heat capacity means that ability to store heat. So when an object has a higher specific heat capacity, it will take a longer time to be heated up. So that is why I say that power, mass, will, okay, and delta T, I just write down change in temperature to heat it up, right? And change in temperature are constants. Larger specific heat capacity takes longer time to heat water. You can write down this equation. PT equals MC delta T. So you have to explain, okay, where P is the power of the heater, T is the time taken, M is the mass, C is the specific heat capacity, and delta T is the change in temperature. In temperature. That's it. Now let us move on to question number 5. Fig 5.1 shows two containers, each filled with hot water. The outer surface of the metal container is hot. A. Explain how electrons transfer thermal energy through the metal of the container. You know, the good thing about the metal is that the metal can transfer the heat faster as compared to non-metal. Why? Due to the free electrons that contain inside the metal, right? So how do electrons transfer the thermal energy throughout the whole metal container? First of all, electrons must absorb the heat. From where? From the hot water. So when the electrons absorb the heat from the hot water, the electron will gain energy. So that heat from the hot water is being transformed to the kinetic energy of the electrons. So when the electrons, because they are free to move about inside the metal, so they have more kinetic energy. When they have more kinetic energy, they can move faster, they can drift faster with higher speed. When they drift, right, along the metal or throughout the metal, at some point they will collide because it is not about the electrons inside the metal. There are also atoms which are closely packed inside the metal. So these electrons will collide with the metal, make contact with the atoms inside the metal, right? So that is how the heat is being transferred to the other atom. And then these electrons will also collide with themselves, each other. That is how make the heat transfer even faster throughout the whole metal of the container. That is why I say electrons absorb the heat first so that they have higher kinetic energy so that they can drift along the metal or throughout the metal with high speed and collide with themselves as well as the atoms of the metal more frequently to pass the heat until the heat reach throughout the whole metal. Now, B, the outer surface of the non-metal container is much cooler as compared to the outer surface of the metal container. Explain why non-metal conducts thermal energy less well than a metal. I thought I reviewed the answer just now, right? I said that because metal contains free electrons, whereas non-metals have no free electrons to help them to conduct the heat, right? So the answer is non-metal does not contain delocalized electrons. Or you can change it with, if you don't like the word delocalized, you could also replace it with free electrons, electrons that are free to move about, to transfer heat. C, explain in terms of particles why gases are poor thermal conductors compared to non-metal solids. Now, they ask you to compare between the state of metals. What is the difference between solid and gas? Solid are closely packed. I mean, the atoms are closely packed, whereas the gas particles are far apart from each other, right? So that makes the heat takes a longer time to reach the other particle which are far apart in gas. So I would say that gas particles are far apart from each other. So it takes longer time to transfer heat from one particle to another. That's the reason why. Question number 6. Number 6, fig 6.1 shows a thin converging lens used to produce a magnified image of an object AB. Now, A, explain the meaning of the terms principal focus and focal length. These two terms are super duper important. So I said that principal focus, you have to put this down. Principal focus is a point in which all the rays, or you can say all rays or all light, is up to you. All rays will be directed to or focused to when rays passing through a converging lens. What about focal length? Length means distance. Distance from where? Distance between the center of the lens, the one that they draw a dotted line here, to the principal focus. That is called focal length. It is distance between center of lens and principal focus. Please make sure that you know the definition of these two terms. It is super duper important. Now, part B, on fig 6.1, draw the magnified image of AB. Show your working. I am going to draw it right now. So let me scroll up a little bit. Scroll up and get my ruler. So first of all, whenever you draw a ray that is horizontal. A ray that is horizontal must be refracted towards the principal focus. So how do I draw it? Okay, make sure that my ruler. Okay, where's my principal focus? It is here. So it is here. Here, for magnifying glass, you have to bear in mind the image will be formed in front of the lens, which is at the same side as the object. So that is why I draw a dotted line here, because image formed in front of the lens must be a virtual image for lens. So you have to remember that. So that's why I draw a dotted line. So you don't just stop there, because you need to draw arrows, ray, how the ray being refracted after passing through the lens. Now, the second ray, which we use the second rule of drawing the ray diagram for lens, is that any ray that passes through the center of the lens, passing through the center of the lens, let me see, is this correct one? Okay, maybe good target. Maybe here. Any ray that passes through the center of the lens will just go through straight. It would not be refracted. So could you see that if I extrapolate my ray? So they will meet at one point on the left-hand side. So I'll keep my ruler first so that you can see. Keep the ruler. So this is the intersection of the two rays to give you the exact location of the image that is being formed. So since they didn't ask me to label the image, so I will just leave it like that. But hey, remember, in order for you to score the full marks, you have to remember to draw arrow for your ray diagram. Arrows are very important. So I would just label here as image. So how do I know that the image is magnified? Because when you compare the height of the image must be compared, start from principal axis. This is the one. So this is the height of the object and this is the height of the image. Could you see that image is clearly taller as compared to object? Now, question number 7. Fig 7.1 shows two charged metal plates. X marks the position of the center of the space between the plates. A, part 1, on Fig 7.1, draw at least 4 field lines to show the pattern and the direction of the electric field between the two charged plates. So whenever we are asked to draw, bear in mind another thing is that when you have two plates, parallel plates, they are facing each other, right, in the opposite direction like that, this is called uniform electric field. So you have uniform electric field, meaning to say that you have to draw equal distance, equal separation between two field lines. Make sure that they are almost equal. Distance must be almost the same. I mean, the separation between the field lines must be almost the same. They say at least 4, so I can draw more than 4, right? Okay, I draw this one and the last one maybe here. Okay, slightly different here. So I'll keep my ruler first. Oh, this one is slightly, okay. Okay, bring back the ruler. So I'm going to draw here. Okay, and I'm going to keep my ruler. Make sure that electric field lines will always flow from positive to negative. Okay, separation means the distance between these two field lines must be almost constant. This one seems to be a little bit smaller. Now, the second part, describe the effect of a negatively charged particle placed at X. When negatively charged particle is being placed at X, what happens here is that negative and positive will be attracted. The negative particle will be attracted to positive plate, whereas the negative particle will also be repelled by negative charged plate. So I say that it accelerates towards positively charged plate. B, during a thunderstorm, an electric field is set up between a cloud and the ground. Charges on the cloud and on the ground are showing in Fig 7.2. The lightning shown in Fig 7.2 discharges a current of 28,000 ampere and or 0.0012 second. First part, calculate the charge that flows from the cloud to the ground. When the current is being given and the time is being given, I just use the equation Q it, right? Q represents the charge, I represents the current, which is 28,000, and T represents the time, which is 0.0012. And you will get 33.6 coulomb. Remember, the unit of charge is coulomb. 33.6 coulomb is the answer. The next one, the lightning transfers 1.2 times 10 to the power 8 joules of energy. Calculate the potential difference between the base of the cloud and the ground. I am using energy is equal to VIT. IT is actually representing Q. So that is why I just replace E equal to VQ. V, I have to find energy is 1.2 times 10 to the power 8. V, Q is the charge that I determined just now, 33.6. V is equal to 1.2 times 10 to the power 8 divided by 33.6, and I got 6 volt. It is a large potential difference by the thunder, so the lightning, which is very, very dangerous to human. So 3.57 times 10 to the power 6 volt is the answer. Now, question number 8. Fig 8.1 shows images produced during two different medical scanning procedure. A, part 1, define ultrasound. Ultrasound sound is a longitudinal wave. A longitudinal wave which the frequency is above 20 kilohertz, above our normal human's audible range. Do you know what is the frequency of audible range of normal human? It is 20 hertz to 20 kilohertz. Now, the second part, state how the speed of the sound in liquid compares to the speed of the sound in air. Speed of the sound in liquid is higher, which is about 1,500 meter per second to 2,000 meter per second, whereas the speed of sound in air is about 330 meter per second to 340 meter per second. So I would say speed of sound in liquid is higher. Now, third, X-rays are part of the electromagnetic spectrum. State the speed of X-ray in vacuums. X-ray is one of the electromagnetic spectrum. All the electromagnetic waves travel with the speed of light in vacuum as well as in air. So the speed is 3 times 10 to the power 8 meter per second. Now, B. Describe 3 similarities or differences between the use of ultrasound and X-ray in medical scanning procedure. So first one, both of them are being used to scan internal body parts. They'll be like avoiding you from undergoing any surgery. So you can see what is happening to your heart, to your bone structures, etc. But the differences is that X-rays is more harmful due to the frequency of the X-ray is very high. X-ray has a very high energy. That is why X-ray can penetrate through your body. And X-ray, due to it has a high penetration and high radiation, because X-ray is one of the radiation, it can kill a lot of cells of your body compared to ultrasound. Ultrasound is just a sound. So ultrasound is based on reflection. So you just direct the ultrasound to your body, and then this ultrasound will be reflected by your bones or your boundaries, soft tissues towards the transducer, which is detecting the ultrasound, and then they will feed back to the computer to see what is happening. Now, question number 9. Fig 9.1 shows the mobile phone or your cell phone being charged on a wireless charging plate. This is quite popular nowadays, right? You just put it without wires. A, when the charging plate is switched on, there is an alternating current in the primary coil. A secondary coil is in the mobile phone. This is like the working of transformer, don't you think so? Explain how a current is being produced in the secondary coil. So look at how I answer it. 3 marks, therefore you need to have the 3 points. I said that because primary coil is being connected to alternating current. That is why the alternating current produces alternating magnetic field. Alternating, this is the alternating current. This is a graph of alternating current if you want to know. This is a time. This is the alternating current, which changes its direction every half a cycle. So you could see that, okay, this is alternating current, which changes its direction every half a cycle. So since the direction, because magnetic field depends on the current. When the current changes the direction, when the current is decreasing or increasing, so does the magnetic field. So the alternating magnetic field is being cut by the secondary coil, which causes a change in the magnetic field. According to Faraday's law, a change in the magnetic field will induce a current. That is how the current is being induced in the secondary coil. Now, B, the maximum energy stored in the battery of the mobile phone is 0.012 kilowatt hour. Show that this maximum energy is 4.3 times 10 to the power of 4 joules. Right, they give me kilowatt hour, which is the power. I need to find energy. Energy is power times time. So I just put in 0.012 kilo is 1,000. So you have to times 1,000. And this is hour. You need to change to second. 1 hour has 60 minutes. 1 minute has 60 seconds. So after that, you should be able to get 43200 joules, or you round it off to 4.3 times 10 to the power of 4 joules. Now the second part, the charging plate in Fig 9.1 has a useful output power of 15 watt. The phone manufacturer claims that the battery can be charged to 50% capacity in less than 30 minutes. Wow. Show that this claim is true. They give you 3 marks. I am definitely going to show that. I will find my input energy because they give me the output energy. So I need to find my input energy and check whether my efficiency of the phone can be charged to 50% in less than 30 minutes. So I use energy. Energy is equal to power divided by time. Oh, sorry, this is a wrong equation. It is supposed to be power is equal to energy over time. So I'm going to use power input because power is given. I'm so sorry. It is actually power equals energy over time. Energy is equal to power times time, right? Power input is equal to input energy per time. So the input energy is the energy that I have already shown in B part 1. So that is 4.3 times 10 to the power of 4 and the time. Since the manufacturer claims that it can be charged in less than 30 minutes, so the maximum time used is just 30 minutes, I change to second. And here I got 24 watt. Now, use back the equation of efficiency is equal to useful output power, right? They already mentioned this is useful output power over input power times 100%. Let us see. The useful output power is 15 watt, input power is 24 watt, and I time 100%. With the maximum time of 30 minutes, I get 62.5%. What? 62.5%. What is that supposed to mean? So it means that in 30 minutes, the battery. Now, yeah, the battery can be charged to 62.5%, which is higher than 50%. Therefore, the claim is true. Now, question number 10. Leaks in underground water pipes are detected using radioactive tracers. Fig 10.1 shows a radiation detector above a water pipe. A. Before the radioactive traces is added to the water, the detector measures the background radiation above the pipe. The average background radiation is 26 counts per minute. Define background radiation. Do you know that we are not living in a safe world anymore because the food that we consume, the water that we drink, the drinks that we drink every day, right? The building that we live in, the bedroom that we sleep on, the bed that we sleep on, and then the things that we are using, yeah, give out radiation, right? So background radiation is a radiation detected or initial irradiation detected by detector when the radioactive isotope is not there. So it seems like radioactive isotopes is not there because detector is supposed to detect radioactive isotope, but radioactive isotope is not there. So you just simply switch it on, you detect a reading. So it is a random reading. Yeah, that is called background radiation. So I would define it. It is unwanted radiation, or you can say unwanted stray, because you don't know coming from where, or you can say random radiation detected by detector. So that is background radiation. Now, the second part suggests one source of radiation that may make a significant contribution to the background count rate. Maybe the rocks, maybe the stones, maybe the buildings, etc., soil, etc. Now, third, a radioactive tracer is added to the water. The counter in Fig 10.1 shows the count rate in counts per minute above the leaks in the water pipe. Determine the count rate due to the tracer. I will write it down so that you can understand this better. The count rate due to tracer is equal to where is the detector reading? Okay, detector reading minus background radiation, because it is quite significant. So the detector reading, so you just read from the counter, it is 382. So background radiation is 26 counts per minute. So I take 382 minus 26. You get 356 counts per minute. So 356 counts per minute is the answer. Now, B suggests which radioactive emission, alpha, beta, or gamma, is suitable for detecting the leak in the water pipe. Explain your answer. Now, I want you to see this. Alpha is called helium nucleus, 42He. Beta is fast-moving electron. Gamma is just an electromagnetic ray. So I would say gamma. Why? Because alpha would be stopped by few sheets of paper, whereas beta could be stopped by a very thin aluminum sheet. What about the leak in the water pipe? It is way thicker. That is why I need to use a gamma, because gamma can penetrate through water pipe. Gamma has a strong penetrating power. C, part 1. Explain why the radioactive isotope must not have a very short half-life. You don't want the half-life to be short because you need time to detect and you need time to interpret what is happening. Is that a leakage or no? Right? If the half-life is very short, it serves no purposes. Right? So I said that so that it can detect the leak in water pipe in time. Now, the second point. Explain why the radioactive isotope must not have a very long half-life. After you have detected leakage in the water pipe, we want the radioactive isotope to decay completely, right? Because you don't want the radioactive isotope to stay too long in the water and contaminates the water supply. So that's the answer. So that it does not stay in water and contaminates water supply. That's it. Now, the last question, number 11, a galaxy is approximately 1.2 times 10 to the power 26 meter from the Earth. A scientist observed light from the distant galaxy. Wavelength of the observed light is longer than the wavelength of the light emitted from the galaxy. State the name of this effect. It is always redshift. B part 1, state the current estimate for the Hubble constant H naught. It is 2.2 times 10 to the power of negative 18 per second. Now, the second part, calculate the speed at which the galaxy is moving away from the Earth. I use Hubble constant. It is used to predict the galaxy, how far the galaxy has moving away, speed over time. So 2.2 times 10 to the power negative 18 is equal to speed over 1.2 times 10 to the power 26. So cross multiply, the speed is 2.2 times 10 to the power negative 18. times 1.2 times 10 to the power 26. So the answer is 2.64 times 10 to the power 8 meter per second. 2.64 times 10 to the power 8 meter per second. Now, third, scientists have measured the speeds at which the distant galaxies are moving away from the Earth and their distances from the Earth. These measurements suggest that all the universe was once a single point. Explain why. Big Bang Theory, remember? Right? The universe starts from a small point. So it is now because that the universe is expanding and it keeps on expanding even until today. And since the universe is expanding, all the galaxies are moving away from Earth. Goodbye, all the galaxies, because we are getting larger and larger and larger. So that is called Big Bang Theory. So that's the end of the discussion. Thank you very much for watching. I hope all of you score excellent result. Bye. See you again.